What's good, guys? Welcome back to another video. Today we're going to be going over something that a student sent me. Right now they are preparing for a pre-calculus test, mainly on trig. I already made this, but unfortunately my mic was not on. Now we're all good, so we'll do this all over again. So without further ado, once again, let's get right to it. All right, so the first question reads, sketch theta of 17 pi over 7 in standard position. Okay, so let me draw this. We got theta, in other words, the degree, is equal to 17 pi over 7. Well, how do I do this? The first thing that I'm going to do is I'm going to recognize the fact that this is actually a coterminal angle, meaning that this is, well, coterminal to the principled angle or the reference angle in this case, um, meaning that the way that trig works is trig goes around in a circle, just like this, over and over and over again. So in other words, no matter how many times I go in this little loop-de-loop, I get back to the same answer every single time. So that first rotation is all that I actually care about, because after that, it's just repeating itself. So what I have to do is I have to delete that rotation. Well, what is that rotation? That rotation is 2 pi. One rotation around a circle is 2 pi. So I'm going to subtract that. In order to do that, I need a common denominator. So 14 pi over 7. That's going to give me 3 pi over 7. Now, in order for me to figure out or sketch this graph, there's two ways I can do it. One, I can notice that this is about 1/2, meaning that my angle is probably something like this. The other thing is I can actually turn this into degrees. The way that I would do that, pi, remember 2 pi is a full rotation, also known as 360. So 1 pi is 180. So I'm going to replace pi with 180 over 7. 3 times pi is 540 over 7. 7 goes into 54 7 times. With 5 remaining, 7 goes into 50. 7 times with 1 remaining. So I got 77 and 1/7 degree. Pretty close to 90, so it looks like that. All right. Find one positive and negative coterminal angle. Okay, one other thing. Going back to that question before. One positive and one negative coterminal angle. Well, 17 pi over 7. I found one positive coterminal angle, which is 3 pi over 7. In other words, coterminal angle just means the same exact angle, just adjusting the rotation, right? One more rotation, just one more rotation, or one less rotation. So that's my positive one. If I want to find a negative one, I'll just subtract 2 pi again, so minus 14 pi over 7, and that would give me 11 pi over 7 negative. So these would be my two coterminal angles. Now on to the next one. All right, next one reads like this. If cosecant of theta is negative 7 over 2 and tangent's greater than 0, sketch theta in standard position and evaluate the remaining 5 trig functions. Okay, so let me draw this again. I know that cosecant equal to negative 7 over 2, and I was also given that tangent is greater than 0. Okay. Well, first thing that I got to understand here is cosecant of negative 7 over 2. Well, where is that at? Well, one way I can figure that out is instead of doing cosecant, I'm going to do sine. Cosecant, sine is a lot easier to deal with. Now, why I know that cosecant's with sine, the way that I like to think about it is sine and cosine are such good friends. They always have to be together in some form. SC is always combined. So sine is with cosecant the same way that cosine is with secant. So in this case, this is sine. And remember, cosecant is just sine flipped over, so same thing the other way around. Negative 2 over 7. All right. Now, in order for me to solve this, what I have to do is I have to recognize, when is sine negative? Well, sine is negative when any time the y values are negative. So quadrant 3 and quadrant 4, right here on the bottom. But that gives me two possibilities. So how do I figure out which one? Well, that's what that second part tells me. Tangent's greater than 0. So tangent's positive when either cosine and sine are both positive or cosine and sine are both negative. That only happens in this first quadrant and this second quadrant. So, or this first quadrant and this third quadrant. Well, it's not in the first quadrant because sine would be positive in that case, so it's going to be this third quadrant here. So I'm going to draw my little triangle. Now, I know that this is 7, and I know this is negative 2. The reason why is because sine is opposite over hypotenuse. 7 has to be positive because a squared plus b squared equals c squared. 7 always is going to be positive in that case because they're both getting squared. Making this -2. So then I have to find the remaining side. So in this case, -2 squared plus b squared equals 7 squared. So 4 plus b squared is 49. So b squared equals 45. B is equal to the plus or minus the square root of 45. So b is equal to plus or minus 3 root 5. I just separated 45 out into 9 times 5, and the square root of 9 is 3. Now it's plus or minus, but in this case it has to be minus. Because x has to be negative here, right? Because all my x values here are negative, so that's the reason why. Okay. So now, in order for me to find the rest of my trig functions, I'm going to plug in these values for the corresponding ones. So far I got cosecant and sine. Let's just do cosine is equal to adjacent over hypotenuse. So in this case, -3 root 5 over 7. Okay. Secant is that flipped over. So in this case, -7 over 3 root 5. But I got to multiply the top and the bottom by root 5 because you're not supposed to have a radical in the denominator. So this is equal to -7 root 5 over 15. Again, anytime you multiply a radical by itself, that just equals the number under the radical because you're basically undoing it, and then times 3 is 15. All right, tangent. Well, that's equal to opposite over adjacent here, so -2 over -3 root 5. Same thing. That's going to end up equaling 2 root 5 over 15. Negatives cancel out. And then the last one is cotangent, which is equal to adjacent over opposite. So this one's going to be -3 root 5 over -2, which is just equal to 3 root 5 over 2. And you're all set. All right, next one says, solve the equation for theta on intervals 0 to 2 pi. You should have two solutions for the cotangent of -√3 over 3. All right. First thing that I got to do is I'm going to change this cotangent to tangent. So right now, I know that cotangent right here has clearly had its denominator radicalized. The fact that I have 3 and then root 3, I know this has been radicalized. And in fact, it's going to be 1 over root 3 negative. Okay, so now that's cotangent, which means to me, tangent is just that flipped over, which equals negative root 3. All right, if you didn't know that this was the radical, what you could do is you could just flip it over and then rationalize the denominator. And that would give you 3 root 3 over 3, and the 3's cancel out, leaving with root 3. So that would be the other way you get there if you didn't see that this was rationalized. Okay, so now that we know that tangent is equal to root 3, this takes a little bit of unit circle knowledge. So if you don't remember the unit circle, the way that I remember it's like this: 3, 2, 1, 1, 2, 3. Why? What is that? Well, the only angles you got to know are 30, 45, and 60 degrees. And the order that they go is 3, 2, 1, 1, 2, 3. Now, it's a little bit more complicated than this, but that's the main thing that you have to memorize. The reason why is because all of these are divided by 2. So that's not anything that you have to think about. They're all divided by 2. Now, the next thing here is that all of the numerators are actually square rooted. What's the square root of 1? 1. So this is square root, square root, square root, and square root. Now that is all you got to remember. They do go around the whole unit circle, but the only thing that changes is actually the sine values, which we'll go through. But for now, that's all you have to think of. So now we got to think, okay, tangent sine over cosine, sine divided by cosine. So which one of these two numbers, when divided, is going to equal root 3? Well, we know that sine is on top. Sine is y. So the fact that I have root 3 here means that the sine value has to have root 3. In other words, 60 degrees. Now let's see. Root 3 over 2 divided by 1/2. Well, that's the same thing as times 2 over 1, right? Anytime you divide by a fraction, it's the same thing as multiplying by the reciprocal. See how these cancel out, leaving you with just root 3 over 1, also root 3. Okay. So now I know that tangent is equal to, of negative root 3 is equal to 60 degrees, or in radians, right, the pi version, pi over 3. Again, 180 divided by 3, also equals 60. But it's negative. So when is tangent negative? It's not negative in the first quadrant. It's actually negative in the second and the fourth. So what I got to do is I got to adjust these accordingly. Well, how do I change it to the second? Well, it's going to be 180. Notice this is a flat line minus the angle that this was provided here, and that gives you the remaining angle. So 180 minus 60, that's equal to 120. So that's one of the answers. I'll do the same thing with radians here. This, in this case, 180 is the same thing as pi, which is 3 pi over 3, which ends up being 2 pi over 3. So again, that's the same answer here. Now, in quadrant 4, it's kind of the similar idea, except instead of 180 minus theta, it's going to be 360 minus theta, giving us a second answer of 300 degrees, or in the case of over here, it's going to be 6 pi over 3 minus pi over 3, being 5 pi over 3. There you are. On to the next one. All right. So 4 through 11, the rest of the questions here, all read, find the exact value of each of the following. And the first one that they give us is 13 pi over 6. So sine 13 pi over 6. Well, the first thing that I'm noticing, again, is that this has one too many rotations, right? So what I'm going to do is I'm going to take that rotation away, which is 12 pi over 6. Which ends up giving me pi over 6. Well, what is pi over 6? Pi over 6 is 180 divided by 6, which is 30 degrees, which 30 degrees is in the first quadrant, and it's actually one of our special angles. And again, 3, 2, 1, 1, 2, 3. So it's that first one, right? Because 30 degrees is the first one, 1, which ends up equaling 1/2, making that your final answer. All right, so now we have the tangent of negative 2 pi over 3. So the first thing I'm noticing is negative, but tangent's odd. What does that mean? Odd trig values have this identity, which is, let's say in this case, the tangent of negative u is equal to the negative tangent of u. So the best way for me to explain this is not to use tangent, but to use sine, because sine is also odd. So if we look at this on a graph, sine looks like this, right? But if I take it to the negative side, down here, this is pi over 2. This is negative pi over 2. So notice that when the actual degree value, in this case the radians, flips signs, the answer also flips signs. In this case it was positive, and in this case it's negative. So that's the reason why it's odd. So in other words, whenever the actual value, your u value, your theta value in this case, is negative, the value that you get, the actual function itself, flips signs. So in this case here, if it's positive, it stays positive. If it's negative, it stays negative. If the sign flips, right? If we go from negative to positive, this also flips. We go from negative to positive, and vice versa the other way around. So, first thing that I'm thinking of here is, well, what is the reference angle? So the reference angle in this case is pi over 3. The reason why I know that is the fact that it has 3 in the denominator, so I know it's going to be pi over 3. Well, what is pi over 3? That's 60 degrees. And so then I got to think, okay, 60 degrees, 3, 2, 1, 1, 2, 3. Sine is 3, so 3 root 2 divided by 1/2. In other words, square root 3. Well, this is in the second quadrant right here, because it's 2 pi over 3. And so I know that this is actually the square root of negative 3, but I have to remember that it's also this. So in other words, the negative tangent of negative 2 pi over 3, or of 2 pi over 3, right? Because I have to say it's equal to this, is equal to negative, this negative. Well, tangent of 2 pi over 3 is negative root 3. So then I have two negatives there. What's a negative times a negative? A positive, giving me positive root 3 as an answer. All right, next one reads cosine of 150 degrees. Okay. Well, first thing I'm thinking of is the reference angle. So in other words, what is divisible by 150? 45, 60, or 30? Well, 45 doesn't go in, 60 doesn't go in evenly. None of those go in evenly, so that leaves me with 30. So cosine of 30 degrees, again, 3, 2, 1. Cosine's first because it's the x value, so root 3 over 2. Now this is in the second quadrant. I know that because it's less than 180, but it's more than 90. Well, cosine must be negative in this quadrant because my x values are negative, making it negative root 3 over 2. All right, now we're switching it up a little bit. We got the sine inverse, though, of negative root 2 over 2. So before we get into this, we got to kind of get a little bit of an understanding of how inverse sine or inverse trig values work. Well, graphically, an inverse means it's 1 to 1, meaning that it passes the horizontal line test. So if I draw roughly what this graph looks like, it looks something like that. Now the horizontal line test means if I draw a horizontal line through this thing, it's only going to touch the graph once. Well, notice that only happens on this interval right here. Anywhere else, notice how it would go through twice. Like let's say, for example, if I go here, see how it passes twice? That means that it's not an inverse function. The only way that happens is right here. Well, notice it happens at the maximum and the minimum value. In other words, negative pi over 2, pi over 2. All right. Now, if we look at a unit circle, pi over 2, this is, in this case, that negative pi over 2 value, technically. And that means that sine and tangent, because they're both odd functions that end up doing this, only happen in the first and fourth quadrant. So we have to keep that in mind. And the reason why is this. So first things first is what is, anytime we're dealing with an inverse function, we're trying to think of the angle. So negative root 2 over 2 is 45 degrees. The way that I know that, it's 3, 2, 1, 1, 2, 3. 2 is in the middle. So I know that this is 45 degrees, also known as pi over 4. Now the fact that it's negative means it must be in the fourth quadrant, because it can't be in the first, because if it was in the first, it'd be positive. And that automatically makes you think, okay, well, 2 pi minus theta. So that'd make you do, 8 pi over 4 minus 7 pi over 4 and get 7, 8 pi over 4 minus pi over 4 and get 7 pi over 4. But the problem is remember, the interval is from pi over 2 to negative pi over 2. That's not in the interval, so it actually doesn't work. So now how do we do this? Well, remember, sine is negative. sine negative u, this still applies with the inverse, is equal to the negative sine u. So in other words, I'm going to do that here. Negative sine inverse of root 2 over 2. Well, root 2 over 2 is just like we said, is equal to pi over 4. In other words, this is equal to negative pi over 4. And that's how you solve that one. Okay, next one. We got arc cosine of negative root 3 over 2. So arc cosine, just so you know, is inverse cosine, same vibe. But we got to think of the same thing last time, because this is the inverse, so I got to think of when this thing passes the horizontal line test. In other words, it's actually an inverse function. So how do I do that? Well, I got to draw the graph. Something like that. If I take it negative as well, it's going to go something like this. Now, the only time it passes the horizontal line test, and in this case, is from 0 all the way down to this value here. So basically from here to here, which ends up being pi. So from 0 to pi is cosines. So I got to keep that in mind. In fact, actually, I'll draw the interval this time. I know that the interval for the inverse cosine is from 0 to pi. Now I got to think about the actual angle. Well, the angle is root 3 over 2. So again, 3, 2, 1. Cosine is 3. That means that this is 30 degrees, which in other words is pi over 6. But it's negative, right? And again, remember, it's from 0 to pi. So if we think about from 0 to pi, that's just from right here, because remember, this is pi. And so that's actually perfect for us, because remember, cosine in this case is negative in the second quadrant. So that actually works. How would I figure that out? Well, I would do 180 minus theta, so root 6 pi over 6 minus pi over 6, which gives us 5 pi over 6. Notice that this value is less than 1, but it's greater than 0, or less than pi, I guess, and greater than 0. So look at that. This works, which means that, in this case, is actually our final answer. Okay, next one. We got the inverse tangent of root 3. Now, I'll just tell you right now that this is pi over 3. We went over this on the last one, so I won't go over why. Just know that this is pi over 3. It's 60 degrees. And then remember, tangent has that interval of negative pi over 2 to pi over 2. So in other words, the first and fourth quadrant, tan is positive in this case, which means I'm dealing with that first quadrant, which actually this is already in the first quadrant, so this would actually be the final answer right here. We're all set. Okay, crazy. Now we're dealing with a composite function, right? I got a function within a function. Anytime you deal with something like this, always work your way from the inside out. So arctangent of 1/4. Well, I know that arctangent for tangent is quadrant 1 and quadrant 4. The fact that it's positive puts me in quadrant 1. So I'm going to draw my little triangle here. And the reason why I'm drawing a triangle is because this isn't one of my special angles, so there's nothing I can really do with it without figuring stuff out. Especially since eventually I'm going to have to take the cosecant of this thing, which is based on sine. So opposite over adjacent here. So opposite is going to be 1. Adjacent is going to be 4. So I got to find this remaining value here. So in other words, 1 squared plus 4 squared equals c squared. So 1 plus 16 equals c squared. 17 equals c squared. Square root of 17. Just like that. Okay, so in questions like this, I got to work my way from the inside out. So arctangent of 1/4, I don't really know what it is because, again, it is not one of those special special angles that were provided here. So what I have to do is I have to find everything based on it. Okay, now I've done that. Beautiful. So now this is basically useless. So what I got to do is I actually have to find the cosecant based on this angle that's been provided, because what this provided us is the triangle. So now what happens is I'm finding the cosecant of that. Well, what is the cosecant of that? and it's 1 over sine. Sine is opposite over hypotenuse. So in this case, cosecant is hypotenuse over opposite. So the cosecant of this triangle here ends up just being the square root of 17. Okay, last question here of the day. I got cotangent of sine inverse of negative root 3 over 7. Bing, bang, bong. All right, so this is the same idea. I know that sine is only quadrant 1 and quadrant 4 for inverse. The fact that it's in quadrant 4, or it's going to be in quadrant 4 because it's negative. All right. Now, again, sine is opposite over hypotenuse. So the opposite side is going to be negative 3. The opposite, or the hypotenuse is 7. Now I'm going to solve for my side here. So a squared plus negative 3 squared equals 7 squared. A squared plus 9 equals 49. A squared equals 40. A is equal to the square root of 40, which is equal to 2 root 10. And I know it's going to be positive because my x values are positive here. All right, so now the inverse sine has done its part. It's showing us where this stuff is. So now I got to take the cotangent of this thing here. Well, cotangent, tangent's opposite over adjacent. So cotangent's adjacent over opposite. That ends up giving me 2 over 10 over negative 3. And look at that. It's actually all good. It's perfect. And that's the final answer for today. If you guys want me to do questions similar to this, homework, help, test prep, anything like that, feel free to drop your questions down in the comments below. I'll look at those and get that out for you. If you like this content or you want stuff done similar to this, always like and subscribe. But until then, I'll see y'all on the next one. Take care. And as always, peace out.